how it works, what you can achieve thanks to the probe. Yeah, 3 use cases, how to use the product, where we can help you, how we can replace the typical NetFlow source data. Then I've got a live demo presentation to show the probe itself, to show the collector and the views in the collector, how to analyze the data, what is possible to see in the collector, in the data. Then as I remember, Magda prepared some survey. She has questions for you. So this will be the end of the webinar. I hope that all join to us right now. So let's start the presentation. Yeah. So the introduction of the Sycope Probe. Probe is a new product in our portfolio. We realized that there is a lot of issues with the quality of the data provided by the typical NetFlow exporters like switches, routers, firewalls. We see some troubles, we see some gaps in the data. So we decided that it's a good idea to prepare the product which fill the gap in this part of the analysis, because as you probably know, if you provide garbage to the system, you will receive garbage at the end of the analysis. So better data in the input means better data on the output. So we decided to prepare the probe, which can be installed in the system to provide extra information about the network traffic. So the first thing, the probe can replace the typical NetFlow exporters like switches, routers, firewalls. You can install it in your environment as a virtual appliance or as a hardware appliance, because it's available in 2 options, in 2 versions. All you have to do is to provide the copy of the traffic to the probe to start the analysis. During the presentation, I will show you how you can provide the copy of the traffic to the probe and how you can start the analysis. The biggest advantage of the probe is that you can install it wherever you want. So you can get the data from the core switch, you can get the data from the DMZ, or you can get the data from one of the internal networks. It's easy to install, it's easy to implement, and in the probe you can get the information about the traffic, but you can also enhance this information with extra fields, extra data. You can also capture the traffic. So the probe, it's not the full packet capture solution, but you can capture the traffic on demand. So if you would like to capture the traffic for some time, for a few minutes, if you would like to capture the traffic between 2 hosts on a very specific protocol, it's also possible to do it. And because of that, there is information about the traffic recording. You can also generate the extra data, not only the NetFlow data, but also the metadata, and provide this metadata to another systems. So it's easy to integrate our probe, not only with the collector, but also with the CM systems or some SOAR systems to provide extra information to analysis. So once again, what is the Sycope Probe? It's an alternative source of NetFlow or IPFix data. We can provide the NetFlow v5, v9. We can provide IPFix with the extra fields, with all the flexibility which is behind the IPFix protocol to the collector. Yeah, we can generate the metadata for another systems, and we can capture the traffic, record the traffic, provide it in the pickup file to additional analysis. So three main points why you should use the probe, because it's easy to install. There are two ways to install the probe in your environment. You can use the span or mirror port on your switch or router to provide the copy of the traffic to the probe. Then probe will analyze the packets, will generate the NetFlow or IPFix data, and will send it to the collector for additional analysis. So you can use it in this way. In this case, it's easy to analyze the traffic from many interfaces of the switch, from many places. You can see all the traffic. You can also use the tab device or packet broker to put it on the cable, on the line, create a copy of the traffic, and provide the copy of the traffic to the probe. In this case, it's possible to analyze the traffic with the full speed. I mean, 1G, 10G, even with the higher performance. In this case, because the tab device or packet broker will split the traffic into two ways, the ingress and egress communication, it means that you need to assign more interfaces to the probe to analyze the traffic, to analyze the data. Okay, then we've got easy configuration. To configure the main part of the probe, it's necessary to configure only, I don't know, 4, maybe 5 tabs in the GUI. It's not necessary to do anything else. So at the beginning, you have to assign the license, then you have to assign the resources to the system. Yeah, configure the flow exporting, and at the end start the analysis of the data, start sending the data to the system. Yeah, and the third stage of the usage is usage it in the system. So because the collector has predefined many dedicated dashboards, many predefined widgets to analyze the data, the traffic, it's possible to use it. It's available out of the box, so you don't have to configure anything extra, anything else. Everything is available in the system. You've got predefined views to analyze the performance, the extra data, or just analyze the data itself. So I will show it to you during my presentation, how to analyze the views, how to filter the data, how to work with it. Okay. As I said at the beginning, I prepared 3 use cases, why and how you can use the probe in your environment. The first use case is the case which is very popular. I mean, generating NetFlow data when your typical exporters cannot do it, or you don't want to configure the flow exporting on your network devices. Why? There could be a lot of reasons, because you don't want to enable another process on your network devices, because they cannot send the NetFlow data, or because there is some issue with the NetFlow data. So, for example, your switches or routers can generate only the S-flow information. S-flow means sampled flow. It means that we do not see everything. We see the information about the communication, but with some sampling. I mean, 1 of 1,000 packets, 1 of 1,000 connections. It can give us some information about the statistics in the network, but it will not give us the full information about the network traffic. We will miss something in the data. And because of that, we don't want to use the S-flow protocol to provide the data for the analysis. What else? Maybe there is a bug in the firmware which cannot generate the proper NetFlow data. We see the NetFlow, but we also see some issues like empty field with the TCP packets. We see the incorrect number of packets, of bytes. We do not see everything. For example, we do not see the information about the VLANs. We do not see the information about the other important things like DSCP fields or something like this. In all those cases, it's possible to replace the typical NetFlow exporter with our probe. Yeah, as I said, it's necessary to install the probe as a virtual or hardware appliance. Depends what you want, depends what you need, because we know that the virtual environments are more flexible, but they are also not so fast. There's a lot of issues with the performance, with working with speed higher than 10 gigabits. So maybe because of that, it's necessary to use the hardware appliance. It's possible to do it. All you have to do is to provide the copy of the traffic from your network devices or through the tap device to the probe and start generating the proper NetFlow data. Okay, the second use case, it's a layer 7 visibility. Typical flow exporter like switch or router do not analyze deeper than to layer 3 or layer 4 and layer 4. Switch don't want to analyze the payload of the packets because don't have to. Router do not want to analyze everything. So usually in this data, we see that, okay, it is a, for example, HTTPS communication, but we don't know what does it mean. It's encrypted, of course, but we can also analyze what kind of the application is behind this encryption. how we can do it. Thanks to the payload analysis, our probe receives copy of the full communication. We see every single packet of the communication, so we can analyze the payload, because it's dedicated solution to analyze the packets, and we can detect the real application in the networks. How it works. We see the full communication, and we can analyze and find some patterns in the network communication and tell that it's encrypted communication, but for almost 100%, this is the application like this. Why? Because we can analyze the communication. For YouTube, at the beginning, we see that this is the certificate, that this is the communication signed by Google. We see some very specific kind of the communication, because the video is buffering by the computer. So we see that this is a very specific kind of the communication with the buffering. For application like Teams or like Click Meeting, we see that it looks like a stream, like a streaming. We see that the packets have no full payload. This is not the maximum size of the packet. We see the communication, which takes a lot of time, because it's during the whole meeting, and we see that we send and receive some data. So we see that this is the two-side communication. It's not only downloading some data, but we are also sending some data. So it looks like the meeting communication. So we can, thanks to the analysis, we can tell that, okay, it looks like Teams or like Click Meeting or like Google Meet or something like this. We can analyze the behavior of the communication. We can analyze the payload of the communication, and we can tell that it's encrypted. It's HTTPS communication, but it also looks like this specific application. I wrote that we can detect over 250 applications, but it's almost 300. It's like 290 something. So it's almost 300 applications which we can detect and tell that it is the application like this. What else? We can also analyze the layer 7, the payload of the communication, and we can analyze the extra fields in the system. Here you can see 3 examples for DNS, HTTP communication, and also the analysis of the JA3 hash to detect some specific applications, some specific connections. I gave these 3 examples because it's also predefined in the system. So in the system, in the collector, it's necessary to enable the function to save extra fields which are well known in the communication. So you can save the extra fields for DNS, for HTTP protocol. You can save extra fields for the JA3 hash. But our probe can also analyze few others protocols. So it's possible to analyze also the protocols like TLS, like SIP, FTP, SMTP, MySQL, DHCP. So you can analyze few other protocols this integration is not available yet in the collector, but you can add this fields manually to the system and start the analysis of the data. In the next releases, we will put this integration on the higher level, and it will work in this same way as for DNS or HTTP protocol. So you can add these extra fields to the collector and using this field for searching, analyzing, and visualizing the data. Okay, and the third use case, it's connected with the network performance. Probably you know the issues with the network performance, that someone is telling that the network doesn't work well, but you don't know why. Is it the problem with the client, with the server, with the application, or maybe this is the problem with the is a problem with the physical infrastructure, like broken cable, broken network interface. In case like this, probe can measure the performance metrics. We can measure three metrics. The first one is server network time. The second one is client network time, and initial server response time. To explain you this delays, I prepared the slide. Yeah, so you can see that the server network time, it's a time between the request and the reply from the server. So we see how fast the server replied to the client. Then we see the client network time. This is the confirmation for this reply. We see another value, which is client network time. The sum of these two parameters is known as a round trip time. So you can tell that this is the network delay. And the third parameter is initial server response time. It's a time between the request to the application and the first response from the application. So we can tell, is it the problem with the client, with the server? Is it the problem with the network itself, because maybe it's a problem here and here, or we can tell that this is the problem with the application. We can also analyze the retransmissions. So in this place, we can see that there are a lot of retransmissions in the network. I remember few networks where I saw like 20% of the packages were retransmitted in the network. So you can imagine how slow was the network because of the broken cable, the broken interface, or some issue with the hardware. So we can analyze a few performance metrics to show you the information in the system. Okay. This is the end of the PowerPoint presentation. So it's time to go to the our main part of the presentation to show you the interface of the probe, of the collector, and how to analyze the data in the system. As you can see, my probe is connected to the network. I see some traffic on the interface. I can analyze the traffic. I can see which protocol is used in the network. I see some TCP packets. I see some UDP packets. I see, I would say, the basic information about the network communication. We don't use it to the analysis, but in probe we can see that, okay, we see the communication, we see the packets, the data, so we can start the analysis. So to start the analysis, at the beginning we should assign the resources. Yeah, so I decided to assign some resources for the IPFix process, for capturing the data, to analyzing the network traffic. It's easy to do. You can also assign more resources to some process to optimize the system. If you would like to capture the traffic, you can assign the resources for the capturing process. If you don't want to capture the traffic, you can just remove the capturing from the system and assign these resources to another process. So this is the part of the customization. I think that it's necessary to configure it once, and you can forget about this displays. The last thing to configure is to configure the profile of the IPFix process. So in this place, you can just tell to which collector the data should be sent, on which port. Yeah, you can configure the timeouts to the system. Of course, we'll give you some recommendation how to configure this value. You can also set up which fields should be visible in the system. So we can configure the information like, of course, IP addresses, ports, protocols, but you can also put the information about the VLANs, about the MAC addresses, about the TCP flags, or you can assign a lot of additional examples how to analyze the data and what other fields should be visible in the system. In my system, in this system, I decided to configure the information for the performance of the network, to assign the information about the DNS and HTTP and TLS protocol. So this is all you have to do. As you can see, you can create up to 16 processes to export the data. So in this case, our collector can be only one of the destination for the data. This is the end of the configuration of the probe. As you can see, it's easy. It's easy to configure it. It's not a time-consuming process. I think that you have to do it once and forgot about the system. The core of the analysis is in the collector. Probably you know the interface of the collector. On the main part of the screen, you can see the dashboard. You can see the data to analyze. On the top, you've got the search bar to filter the data, to set up the proper time frame to analysis. And on the left side of the screen, you've got the you've got a menu to switch between the windows to analyze the data. Yeah, so you can set up your home screen to start the analysis. This is the screen with the application overview, so we can see that the data is visible here. Okay, so what can I analyze? Let's start with the DNS data. Yeah, we've got predefined dashboard for DNS protocol. You can see who is the top DNS client, what is the most popular DNS server. You can see the most popular queries in the network. You can see the most popular query type in the system. You can see how many requests were sent in the network in the last 15 minutes. So let's try to change this time frame to 1 hour. In the 1 hour, we see more queries. Maybe the queries are different than in the past. You can see what was the most popular DNS server for the analysis. You can also create your own view to analyze it only for a specific subnet, to analyze the data only for a specific devices, locations, etc. It's up to you. How would you like to filter the data to see the data in the system? The second view is the view to analyze the HTTP protocol.
Hey Piotr, I think we cannot see your screen now. If you can share one more time.
You can't see my screen.
Just right now.
Okay, let me check it once again. Um,
Okay, it's back. Thank you.
it's back.
Yes,
Okay. So should I show the information for the DNS protocol once again?
it was just like last 30 seconds of your
Okay.
presentation.
Okay. So let's try to analyze the HTTP activity in the network. So in here, you can see the information like top. Okay, maybe let's check the time of the analysis. Okay, you can analyze which browser was used by the client in the network. You can see what was the most popular method to get the data. You can see what was the type of the code of the data. We have to wait for the data for the top host and top URLs. Maybe I will try to refresh the view to see it. Okay. Let's wait for the data. Maybe I will remove this. Okay. Let's go there once again. HTTP activities for the last 15 minutes. We can expand the time to see it for a longer period of time. Yeah, once again, most popular URLs, most popular HTTP hosts, the return code in the network. You can also start filtering the data from here. So you can see what was the most popular client in the network and see the most popular methods, URLs, hosts for this client IP address, or who was the top client for the for our server. You can analyze this data and see this kind of the communication in the system, in your system. Okay. Okay, let's try to analyze the extra fields in the network. Once again, I'm waiting for the result of the analysis, so maybe I will remove it from the filter. Okay, let's try to analyze the extra fields in the data. I add few extra fields like TLS server name, TLS version, TLS cipher type to my database. It was possible because when I try to see what my exporter sends to me, I see some extra fields which are sent by the exporter. I can add this field to my database and start the analysis of this data. I told you that it's possible to analyze the protocols like DHCP, SMTP, SIP. So for now, it will be C as an unknown field in the NetFlow data. It's necessary to add it and start the analysis. But you can also wait some time and we will add the extra fields to our system. If you would like to see how the configuration of the extra field looks like, you have to assign the name, you have to assign the type of the field. You can see the example, so it's also easy to see what is visible in the data here. Yeah, so it's easy to configure the extra field in the database to see this data in the system. And to start the analysis of this data, you can go to the raw data right now, add new column, like TLS, TLS server name. Yeah, and you can start the analysis of the data. For now, it's empty because I have to filter the data for my specific probe. So the exporter IP is, yeah, I've got a few exporters, and I have to use only one of them. Okay, apply. Is it this one? Okay, I have to also put the information that I would like to see the HTTPS communication. So the server port is 443. Okay, can put it here. Okay, so maybe I can also use another data from the another exporter. Let's try to do it this way to see the data not from this one. Okay, now I see the TLS server name. It's visible in the communication. Demo Sycope.com, update Sycope.com. yeah, because this is the communication in my own environment. Probably in the last 2 hours, I should also see some different values. Yeah, like let me check. I generated some extra traffic in my network, so it should be visible maybe for last 2 hours. I did it some time ago. Apply. I will make some exceptions to see the data. You can see the Facebook, YouTube communication. You can see what was behind the real communication. Because of the layer 7 analysis, you can see it. You can create your own statistics to analyze the data. You can also see the most popular encryption methods, etc., etc. So, okay, this is how it works. And let's go back to the third use case. Let's start to analyze the performance of the network. So it's necessary to see the information about the IP address performance or application performance. You can see the information about the server network time, client network time, initial server response time. To start the analysis of this data, you can see who was the top client or top server in the network delay. So here you can see the highest server delay. Here you can see the highest client delay. You can see how it was with the retransmissions, how many packets, how many bytes were retransmitted. You can also select one of the IP to see the statistics only for this IP address. You can see this information on the graphs. You can see this information also in the table. So you can sort the table to see the highest server response time, to see the highest client delays, to see the communications with the highest retransmissions in the network. There were no retransmissions in my network, but yeah, there were some delays on the server, client, and application side. So it's easy to analyze the data. Everything is visible on the predefined dashboard, so it's easy to analyze. As I said, these functions are built in the system. They are available out of the box, and so you can start the analysis. I think that this is the end of the presentation. I think that I showed you everything, the information, how to filter the data, how to see the data, what you can do. Of course, for you it looks probably very strange because it's my environment, it's my data. So I think that it's a good idea to start the POC of the probe, to start the analysis of the system. As I said, the system is available as a virtual machine or as a hardware appliance. We've got some recommendations for the hardware, but it's also possible to install the software on your own platform. If you've got some platform to use, we can provide you the ISO file to install it on the system and start the analysis of your network traffic. So it's easy to use. You've got few ways how to use it, as a dedicated virtual appliance, as a dedicated hardware appliance, or as a software to install on your own platform. All the information about the licensing, about the pricing are available for you. Just give us some information. What do you need? How many interfaces? What is the type of the interfaces to use in the probe? And then we'll provide you some calculations and information about the pricing. So I think that this is the end of the presentation. Okay, I see some questions on the chat, or only one question on the chat. Can you analyze traffic inside the VPN? I would say yes. If your VPN server can provide us the copy of the traffic inside the network, we can analyze it as a typical network traffic. So if you can give us the copy of the traffic from the tunnel interface, we can analyze this communication. If not, if we analyze the data from the physical interface, we will see that this is the encrypted traffic. It's connected with some specific VPN protocol. So depends what kind of the data you can provide us. If it's data from the tunnel interface, we can analyze it. Some other questions? Don't be shy. Just ask. I will answer your questions.
There is no more questions. Maybe
yeah, one more question. Is it possible
Okay.
to install it on the Hyper-V? Yes, it's possible. We will give you the installation files for the Hyper-V. You can install it as an appliance, or you can install it as a part of the system. So, for example, you can install your own platform and just use it on Hyper-V. I do not see any limitations for this platform. It's exactly the same like for VMware. Our collector is available only for VMware, but the probe can be installed also on Hyper-V. No problem. Okay, I see that Magda just give you some
yes.
survey to fill in.
If there is no more question, or someone is more interested in going deeper with understanding of Sycope Probe, I believe Piotr is available to do this personalized demo. So let us know.
Yeah. So maybe let me leave the contact to me. Yeah, you can send me an email. You can call me, and we can discuss about the probe or the entire system.
It's possible also to just mark here in the one of the question that you are interested, and we will
We will back to
contact
you.
you back. Yes. Okay. Thank you so much for the presentation, Piotr,
Thank you.
and
It was a pleasure as always.
we will back to all those who want to have a demo, and see you soon on the other webinar. Thank you.
Thank you very much. Have a nice rest of the day.
Bye. Thank you so
Bye.
much.